Hey everyone, Mr. Fransky here. So we covered our exponential equations. We're going to talk about equations that involve logarithms. So let's take a look. So, key to solving log equations. So, similar to when we had the exponentials before, like we had 7 to the x equals 7 to the x plus 3. Remember, x equals x plus 3, just have to have the same base. Same deal here. You have the same base for both of your logs. Then you can just set the arguments. These are called arguments. It's called the argument of a log. So we're setting the arguments equal to each other. Log base 7, so we got x equals 3x minus 4. So let's see here. Subtract x from both sides, add 4 to both sides probably. 4 equals 2x, x is 2. Not too bad. So the key this time is same base. And also that you have a log on both sides. Sometimes people see a problem like this down here that's a little bit different, and they try to just set things equal, but this is a different problem. You're going to snowman bump this, right? So you're going to bring the 5 over, so we have x plus 3 equal to 5 squared. X plus 3 is 25, so x is 22. Okay? So log on both sides, set the arguments equal to each other. If you have a log on one side, bump it. That's it. All right, now we're just going to do some problems, and that's it. So if you want to try these on your own, you can. Careful with letter B, and see if you can figure it out. If you're going to try it on your own, see if you can figure out why you have to be careful. But we'll talk through it as we go through. All right, so if you give them a shot, let's try them together. So here we got log base 3, log base 3. Argument's got to be the same. X plus 2 has to be equal to 2x minus 3. Okay, so let's see. That means that if we add 3 to both sides, 5 is equal to x. That's it, right? Add 3 and subtract x. Yeah, we're done. 5 is equal to x. Now, it's going to become important later. If you plug it back in, double check. 5 plus 2 is 7. 2 times 5 is 10 minus 3 is 7. So I have log base 3 of 7 equals log base 3 of 7. Checks out. Okay. So this is one we got to be careful on. Let's see what happens. Now, that check on the last one might have been a little hint. Let's see what happens here. So we have x plus 1 equals 2x plus 3. Notice the only difference here is that I had 2x minus 3 and x plus 2 over here. They're very similar problems, though. So let's subtract x and subtract 3. So I have negative 2 equals x. Now, initially, this seems like it should work just fine. But if you plug it back in, you have log base 5 of negative 1 equals log base 5 of, let's see, negative 1 again, right? But the problem with that is, what do logs look like? They look like this, right? Can you take the log of a negative number? No. This is an extraneous solution. Remember that big word? So this is actually not a solution at all. So this has no solutions. So all you have to do here is check. So check your work. Check all your answers. And if you take the log of a negative number, then it's no solution. We're going to get to some where there's a positive and negative, where it's like you're solving a quadratic in here. So one of them might work and the other might not. So just check all your answers. If you have a log of a negative, that's extraneous. Okay, and if none of them work, then you have no solution. All right, let's try another one. Log base 7x plus log base 7 2x equals log base 7 18. So I have to have a clean log on both sides. I have to have log base b of something equals log base b of something. I can't have anything in the front. I can't have anything like added or subtracted. So we're going to combine these. We're going to use our log rules. Remember addition? I can combine these, condense them by using multiplication. So I have log base 7 of 2x squared, just multiply these two things, equal to log base 7 of 18. Now the arguments have to be equal. 2x squared equals 18. So x squared is 9. Now there are two solutions to this, right? X equals 3 and x equals negative 3. If we check up here, negative 3 is no good. That's extraneous. So x equals 3 is our only solution. All right, next up, looks like we have a log on one side. So we're going to combine these two. So we have log base 3 of 1/8 x plus 1 times 8x. Plus 4, that's not a log. So I'm going to move to the other side, equal to 6 minus 4, which is 2. So I have log base 3. If we distribute this in here, looks like 1/8 times 8x is just x squared. And then we would have plus 8x, and that is equal to 2. So now we're going to bump it. Okay, we're going to bump it because we don't have a log on both sides. So we have x squared plus 8x is equal to 3 squared, which is 9. Subtract it from both sides. X squared plus 8x minus 9 equals 0. Quadratic. Let's factor it. X and x looks like a 9 and a 1. looks like plus 9 minus 1. So x could be negative 9 or x could be 1. Well, we better check them. 1 looks okay. 1/8 plus 1, that's a positive number. 8 times 1 is a positive number. But negative 9, nope, that's extraneous. So just x equals 1. That's our only solution. Oh, that's it. That's all the problems I've got. So, love you guys. That's why I'm here. Have a great day.